We want to solve the trigonometric equation cos theta plus 5 is 6 sine squared theta for values of theta between 0 and 360 degrees. Start with our equation. Cos theta plus 5 is 6 sine squared theta. We have the identity that sine squared theta plus cos squared theta is identical to 1, and therefore sine squared theta is the same as 1 minus cos squared theta. We make the substitution into our equation, so cos theta plus 5 is going to be 6 times 1 minus cos squared theta. Expanding the bracket gives cos theta plus 5 is 6 minus 6 cos squared theta, and bringing everything to one side gives 6 cos squared theta plus cos theta minus 1 is equal to 0. So we have a quadratic equation. Factorizing this equation into two brackets, we get 3 cos theta and 2 cos theta, 1 and 1, and this one needs to be a plus and this one a minus. Expanding gives us 6 cos squared theta, take away 2, add 3, giving us the single cos theta, and the minus 1 is equal to 0. Our two solutions, therefore, are cos theta is 1/3 and cos theta is equal to minus a half. Looking at each of these solutions in turn, for the cos theta is 1/3 solution, theta is going to be the inverse cos or shift cos of 1/3 as our principal value, which gives us 70.5 degrees. We can draw that onto our cast diagram. Since we're dealing with a positive value for cosine, the other one will be in the C quadrant. And we're looking for values from 0 to 360. So start with 0. We meet our first solution at 70.5. The second solution is 70.5 before 360, which is 289.5 degrees, and we meet no more solutions on our way to 360. Now considering the other solution, cos theta is equal to minus a half, the principal value for this one is the inverse cosine or shift cosine on the calculator of minus a half, which is 120 degrees. We can locate that here on the cast diagram, and since it's a negative value for a cosine, the other value will be here. Between 0 and 360, we pick up our first solution at 120 degrees, and our second solution just here, 120 before 360, which is 240 degrees. We meet no more solutions on the way to 360, so we've found 4 solutions to the given equation in the range from 0 to 360.